Chapter 19, Weather Patterns and Severe Storms. When we're talking about weather patterns, we have to talk about how the air moves around the globe. When we talk about large masses of air, they're actually called air masses. These are large bodies of air that contain similar temperature and moisture if you look at the same altitude. They move across the globe, usually from a west to an east direction due to the Coriolis effect, and they affect a large portion of continents. When these air masses move from one area into another, they move from a region, and this region is called the source region. This is where it acquires its properties or its characteristics. You can have two types of sources for each air mass. A source either comes from a polar area or a tropical area. Polar areas are higher altitudes, so 60 degrees latitude, 90 degrees latitude, despite whether or not it's in the southern or the northern hemisphere. And then tropical air masses move from the equatorial areas, so low latitudes, and they bring warm air into the area that they're moving to. We also have different sources that the air masses move from. When they move from a continental area, they move from land. They come from a source area that is very dry, so they tend to have a drier characteristic. Whereas air masses that move over water, they tend to be humid because they end up collecting a lot of moisture in their atmosphere. And so those are called maritime. When we talk about different air masses, we combine the latitude and the surface sources to describe the air mass. And we'll say in terms of CP or CT, MP or MT. Here's examples of air masses in North America. You can see how they distinguish between MP and MT in the top left over here. You can see that the maritime polar air mass is coming from the northern direction, or not from the northern direction as much as from the poles, and it's coming over the ocean, so it's called maritime. So it's going to bring cool, humid air in. In contrast, this is a maritime tropical air mass. It's coming from the equatorial zone, so from those lower latitudes, and it's coming upwards. And it's bringing in warm air, and the air is coming over the ocean, so it's coming from a maritime source. So we call that maritime tropical. And you can see it doesn't matter if it's on the east or the west coast of a continent, but they also have the same terms. In America, the western coast is mainly affected by this maritime polar and maritime tropical air masses. And when these air masses reach the Rocky Mountains will cause the air to rise and the precipitation will come out of them. So the center of our country is more affected by a continental polar air mass. And this continental polar air mass is very cold and also dry. So that's why we have a drier climate in the center of our country, whereas on the west coast we have a more moist environment. We also see this maritime tropical air mass really affecting the east coast of the United States of America. This maritime polar air mass that's up here on the top right, while it does affect the Northeast, not randomly, but once in a while, it's not the dominating air mass for the Northeast. When this does affect the Northeast, we call those nor'easterns, and they bring cool, humid weather in, and this causes dramatic storms that last for a long period, we'll say maybe 4 or 5 days, along the eastern coast, and they actually can cause a lot of damage, especially to the Northeast, to our New Jersey coastline. We experience more damage from nor'easterners than we do from hurricanes. Additionally, there's one more air mass that does affect the United States of America, and that's this continental tropical air mass. It comes up from Mexico, and this small, very, very tiny air mass is in here as compared to these larger maritime tropical air masses. These maritime tropical air masses actually cause the continental tropical air mass, this one in orange, to be very isolated. However, it can cause dramatic effects in those areas because it's continental and it's tropical. It's very hot and dry. and it causes our deserts in those areas. If you're in Texas, the weather in Texas is very humid, and during the summer it's really miserable. But if you go out to New Mexico, maybe Albuquerque, you experience this continental tropical air mass, and that dryness makes the weather there so much more enjoyable. When two air masses come together, the boundary that's formed between them is called a front. Whenever you have a front, no matter what two fronts are coming together, warm air always rises. That's because it's less dense. And the cooler air acts as a wedge underneath the warm air. You can see on the right there are some symbols for the different types of fronts we're going to go over. The first is a warm front. And in a warm front, you're always terming the front by the air that's approaching. So the warm front is approaching, warm air is approaching cold air. The warm air is gradually rising over the cold air. This causes a really gradual slope, and it allows clouds to exist throughout a longer span of time and space. It moves slower, and it causes precipitation to be moderate to light as compared to the cold front, which we'll see in a few moments. You can see this red semicircle is the symbol for a warm front when it's drawn on a map. In contrast, a cold front is given the symbol of a blue triangle. Cold air is approaching, it's pushing underneath the warm air, and it's causing the warm air to dramatically rise up at a very steep slope. This causes the clouds to be created, and it also causes thunderheads or cumulonimbus clouds, which cause thunderstorms. When you have a cold front, you have a very fast advancing air mass. It causes violent storms, and it will also move through pretty quickly. This is if you're standing outside and all of a sudden it just starts to rain and pour, but the storm only lasts maybe 5 or 10 minutes and then it's gone out of your area. That would be a cold front that you're experiencing. Afterwards, the sky is pretty clear because the moisture has been precipitated out, and you have cold air that persists. Another type of front is a stationary front. This alternation of the semicircle and the triangle is the symbol for a stationary front. I think of a stationary front as a train station, two trains that are passing next to each other. They're not hurting each other, they're not really affecting each other. They just are existing and they're moving in opposite directions. This doesn't usually happen very stagnantly in nature. Often this will only happen for a short moment and another front will emerge from the way that the air masses are moving around. But in general, this is what a stationary front is. The next type of front is an occluded front. What happens with an occluded front is there's actually three air masses. You have cool air being approached by warm air, and then colder air behind that. Because the cold air is moving faster than the warm air, the cold air will eventually catch up to the cool air, and that warm air has nowhere else to go but to rise upwards. As it rises upwards, it creates a very drastic storm, heavy rain, but since it was also starting to rise up over the cool air that was in front of it, you're having rain for a longer period of time than if it was just a cold front approaching. So, lots of precipitation, a really steep wedge to push the warm air up into the atmosphere. One of the weather systems that we have frequently in the United States of America is the middle latitude cyclone. And a cyclone, as we learned from the other day, is a system that has low pressure in the center of it. And this low pressure, it can happen in what we think of as hurricane cyclones, but this middle latitude cyclone actually happens over the continents. It happens over land, whereas hurricanes happen over the water. As you can see in the picture to the right, this is a system with multiple different air masses moving through. It usually takes 2 to 4 days to move across the whole entire region, moves from the west coast to the east coast. And you can see in the pictures that it starts out as a stationary front, and then the air starts to rotate around the low pressure area, and it becomes a separate cold front and a warm front. And then eventually there's an included front. And so there's a lot of precipitation and a lot of storms going on in a mid-latitude cyclone. You don't need to know specifics about how it develops, but just understand that it is a variety of air masses moving through the location, and it happens over land. So we'll talk about some severe weather types. The first one's a thunderstorm, which is a pretty common weather event that occurs in almost everywhere. Some interesting facts about it is that thunderstorms are actually fueled by the warm surface temperatures of our ground. So the warm surface temperatures of the ground cause air to rise. Because this happens over time, most thunderstorms often occur in the afternoon or the early evening because that's when the ground tends to be warm enough to cause the air to rise. They can happen at any time, but that's just the most common time. And if you look on this map, you can see they happen everywhere in the U.S. They don't happen very frequently up in Seattle, even though we think of Seattle as a very rainy area. They don't happen up there because it's more of a system where the rain is more constant. But they do happen very frequently in Florida, especially in the mid-afternoons. They'll happen, be really drastic, really short, and be done with really quickly, but they happen very frequently. You're used to rainfall and lightning, hail, and thunder all being associated with thunderstorms. And thunderstorms take a little while to develop. They start out as a basic cloud, a cumulus cloud, and then the cloud starts to rise higher and higher. And what you end up getting within the mature stage of a thunderstorm is updrafts and downdrafts. So some of the air is rising, some of the air is starting to fall back down to the ground. And these updrafts and downdrafts are what fuels the storm. And these produce gusty winds, lightning, and hail. At the end of a thunderstorm, the precipitation marks the end of it. And after the precipitation, you will often feel a cooling effect because now the air is less moist, the air is drier, and so it feels cooler. And also the temperature is usually changed. So that cooling effect of the precipitation marks the end of a thunderstorm. The next severe weather type is a tornado, and you'll be doing some of your natural disaster group projects. Someone will have a tornado, so we're not going to get into too much detail right now. But the definition of a tornado, as compared to, let's say, a hurricane, is that it's a very local storm, and it happens for a short time period. It has characteristics that you're probably familiar with: very violent windstorm, that rotating column of air, the vortex. You can also have a lot of other smaller vortices around it, especially if you have a tornado associated within a hurricane. You end up getting a lot of smaller suction vortices. And inside the tornado is a low pressure system. So there are an average of 770 tornadoes per year in the U.S., and they are most common between April and June, but they can happen other times of the year. They usually occur along a cold front because that's when you have that drastic, steep slope of uprise. And thunderstorms are also associated with them. You can see while tornadoes can happen almost anywhere, they tend to happen in the middle of our country, what's called Tornado Alley. And this area has the mixing of the different air masses coming in from the north and the south, which causes the air aloft to be able to create this low pressure system that causes the tornadoes to occur. Two terms that you should be aware of is that when you hear that someone is in a tornado watch, that means that there's a possibility in that location for a tornado to form. When you hear that you're in a tornado warning, that means they've actually sighted a tornado. To me, this is very backwards thinking, but it's just something to memorize. So tornado watch means there's a possibility of a tornado forming. Tornado warning is that it's been sighted. The enhanced Fujita scale, or the EF scale, is what is used to measure the intensity of tornadoes, and it's based on the wind speed. There was an original scale called the Fujita scale, but it was based more on the damage caused by tornadoes. Damage is not a very subjective term because that means that it's not based on any of the characteristics of the actual tornado, but it's dependent on where the tornado touches down, because if it touches down in a populated area, it's obviously going to cause more damage than if it touches down in a field. So it's been changed, and this new scale is called the Enhanced Fujita scale. So you don't have to memorize what the scale is exactly. What you need to know is that Enhanced Fujita scale measures the intensity of tornadoes. And we rank tornadoes on scale from F0 to F5. F5 tornadoes are very violent. We very rarely see them, but they do happen. F0 tornadoes, they actually are very weak, and they're probably pretty frequent, but because they happen so quickly and they actually might not even touch down all the way, they're often not even able to be tracked. They're kind of like ghosts. They happen really fast and no one even knows they're there. So when you look at how many, what the most common tornado is, it would probably be between F1, F2, and F3, because F0s are often not even cited. The next severe weather type is the hurricanes, also known as typhoons in the western Pacific and cyclones in the Indian Ocean. They're just different terminologies given to the same event in different areas. And they're associated with high winds, big waves at sea, and a term that's given to them is the rotary cyclonic circulation. So rotary is rotating, cyclonic is cyclone, low pressure system, and then circulation is also again rotating. Some of the parts of a hurricane that you should be aware of are the eye wall and the eye. If you think of a paper towel tube, right? If you look down inside a roll of paper towels, that space in the center would be the eye. This is the very center. Really, the precipitation ceases. There's no winds. The air is gradually descending, and it's the warm part of the storm, but nothing's really going on there. As compared to the eye wall, which would be the tube that you're actually looking at, the paper tube that would be if you're looking down into a paper towel holder. It's near the center, but what it is, it's a column of rising air. There's a wall there, basically. It's a wall of cumulonimbus clouds that's created by the rising air. The wind is really, really fast here, and there's a lot of heavy rainfall. Additionally, you have spiral bands that flow outwards from the eye and the eye wall. Hurricanes gain their energy from the condensing water vapor of the ocean. They are given categories based on their wind speed also. If the wind speed is not high enough, they can be given categories of a tropical depression or a tropical storm. Since hurricanes gain energy from the condensing water vapor of the ocean, once they move over land or over colder water, they will lose their intensity. They can also lose their intensity when large-scale flow aloft is unfavorable. This may happen when they come into a different zone. We talked about the other day on the circulating Earth that there are different zones, the tropical zone, the mid-latitude zone, and the polar zone. And in each of the boundaries of each of those zones, there's different winds. And these winds aloft could cause the hurricanes to lose intensity. The westerlies do tend to diminish the hurricanes. The Sever-Simpson scale is what is used to rank relative intensities of a hurricane. Again, it's based on wind speed, and our hurricanes are given categories 1, 2, 3, 4, or 5. Hurricanes obviously cause a lot of destruction to both the land and the economy. Destruction from a hurricane doesn't always just come from the wind, but it comes from other aspects too. The storm surge or a large dome of water that sweeps across the coast. Basically, a very big tide. Not quite a tsunami, but a very, very big wave of water will wash into an area and flood the coastal areas. You're also going to have wind damage. The wind is not the only thing that causes damage, but the debris that's picked up by the wind starts to act like shrapnel moving through houses, and that can cause a lot of the damage. And lastly, because of all the moisture held in the hurricane, you can have inland flooding from the spiral bands due to the rain that occurs. So this is a case study of Hurricane Ike. I was down in Texas when Hurricane Ike came through, and so I did some research on it. You don't have to know any details about this. This just kind of is more information about how hurricanes cause destruction. This first picture here, it's a stair rail going down to the water's edge, and that railing is bent. And this isn't because someone skateboarded down it. It got bent during the hurricane. Either the wind or some debris was blown into it and caused it to bend. It wasn't bent before. Hurricane Ike came through Texas at 2 a.m. on September 13th. When it made landfall, it was only a Category 2, but it still had a lot of power behind it. It came through, and the red box that you see on this map is the area of Galveston, Texas, and Houston, Texas. Houston is one of the largest cities in the United States. It came through, and it hit along our barrier island of Bolivar Peninsula and Galveston Islands. The barrier islands in Texas are similar to the barrier islands that we have in New Jersey. When it made landfall, it caused a lot of destruction. Houses were destroyed, infrastructure was damaged. There's a lot of aspects of a building that can get caught on fire and cause even more damaging effects. People were dispersed. They had to leave their homes, set up tent areas or RV parks in areas inland. The picture on the bottom right with the boat that says Sassy, Galveston, Texas, that was taken in December. The hurricane happened in September. So there was still debris all around the roadside, even into the next year. One of the things that Hurricane Ike did was it impacted the ecosystem of Texas. On Galveston Island, a barrier island with a sandy area towards the sea and a marshland towards the back or bay area, had some dramatic effects due to Hurricane Ike. All of those things, the storm surge, the wind, and the inland flooding, caused changes to the ecosystem. This is a picture of an alligator that my friend took while she was doing research on Galveston. It's about as usual to see an alligator on a Texas beach as it is to see one in New Jersey. Been out there plenty of times, and alligators don't just hang out on the beach there. But because they had so many changes to their marshland ecosystem, they had to get out of there and they had nowhere else to go. And so they just started moving around trying to find an area to live because their habitat was destroyed. Kind of creepy. Flooding occurred, especially due to inland flooding and the storm surge. These pictures here show the storm surge that came in. You can see on the left-hand side pictures before and after the hurricane. And this is a wetland area that at one point in time it was saltwater, then it got changed over to freshwater. So on September 9th, that area, all the marsh area you see in green, was actually freshwater. Then September 15th, due to the storm surge, all of that area is now saltwater. Plants can't survive in both types of water often. So the plants now, they are going to have trouble surviving with the saltwater. So it's going to cause a change in the ecosystem due to the change in the salinity of the water. On the right-hand side is a hotel along Galveston Island, and you can see how far it was set back from the dunes, or from the actual coastline. And they're very lucky they set it back, because you can see that the water ended up creeping all the way up over the dunes through that area that was a pretty moist area to walk through anyway. Almost marshy and kind of gross to walk through. But because their hotel was set so far back, it didn't have too much damage as if it was right up along the coastline, such as many of our shorelines and our shore hotels are. I was actually doing research on this beach here, and so after the hurricane I was going to keep doing research, but there was no beach left to do any research, so I couldn't do it. We also have loss of the beach and the dune sand. While beach and dune sand is meant to move around within the ecosystem, when we have developed areas, beach sand will get washed backwards and get lost onto the bay area, or it'll get lost onto the street side, and it will never come back to where it originally was. This is kind of a famous picture on the bottom left. One house standing amongst all the debris. And this is not some trick of the photographer's framing. I was there. This is the one major house standing in this location. Apparently it was a newer house that had better building codes, so it was able to withstand the hurricane. But there was a lot of loss of property too. The stairwell just going to nowhere, RVs being knocked over and moved around. This is some more property damage that you can see, and I put that church in there to show that no one's safe from the wrath of a hurricane. Riprap and debris all along the seawall on the bottom left picture. On the right hand side you can see the Hotel Galvez, and that building to the front of it is just gone after the hurricane. Loss of infrastructure. So roads were destroyed and plowed over by the wind and the surge. A walkway over the dunes. That top right picture, you can see that was a walkway that was actually over dunes. The area that you see in that picture where it's sandy, that was dunes. That was vegetated dunes in those areas. And that walkway was going over this green grassy area. And now it's all gone. In the bottom right picture, same thing. There were dunes underneath those walkways. But in my personal opinion, if a major hurricane comes through your area and all that gets destroyed is your walkway over the dune, you're pretty lucky. Some more pictures of destruction. The top left, I called it the dollhouse. Just the side of the house just ripped off. You can see beds and chairs and just a life in there that was just all of a sudden the hurricane came through and ripped it apart. Refrigerator even. Bottom left picture, it looks pretty good. Those houses look like they're in pretty good shape. But if you're familiar with the area, you would actually know that there were 2 rows of houses in front of those houses that are no longer even visible at all. In the right hand picture, you can see what I call it looks like a tremor from that movie back in the day with Kevin Bacon. These are actually called geotubes, and what they were used for was to stabilize the beaches. They were put along the beaches kind of as an artificial dune. And they left spaces so people could walk onto the beaches without having to climb over them. And where you see the circles on the top picture is where the spaces were left. On the bottom picture, you can see that those circles now coincide exactly with where the major source of the storm surge was funneled in there and caused what's called overwash fans. This is some of the data that I took in the Matagorda Peninsula in Texas, and it's called LiDAR. It's laser image detection and ranging. It's similar to using radar, but what it does is it gives you a 3D image of the location you're looking at. So you can see on the right hand side that bottom picture with the purple and the green. That's giving you a 3D image of the grass and how tall the dune grass is there. So I was able to look at different time periods over a year period and see how the beaches changed in volume from before the hurricane to right after the hurricane, and then for a year after when the beaches were actually starting to recover. So there's always the future to consider. If we're going to rebuild in an area that is hurricane prone, how are we going to rebuild? Are we going to do the same things we did before? Are we going to re-nourish with sand? What sand are we going to use and where are we going to get it from? Or are we going to start thinking about new methods to rebuild? new ways to create infrastructure that maybe can withstand a hurricane somehow. And this is a spaghetti model of Hurricane Irene as it was going through New Jersey or through the East Coast.